Hello and welcome. I am so glad you are here tonight. Wherever you are right now, whatever this day looked like, whatever you are carrying from it, you can put it all down. You do not need it tonight. Tonight belongs entirely to you, to your rest, to your quiet, and to a story that is unlike almost any other story ever told, because every single thing I am going to tell you tonight is true. Tonight we follow two small machines, two spacecraft, each about the size of a small car, built with human hands in the 1970s with technology far simpler than the phone sitting on your nightstand. And yet these two machines are the most widely traveled objects ever created by our species. Right now, as you lie here in your comfortable bed, these two spacecraft are still moving, still sailing through the darkness between the stars, still sending home faint whispers of information across distances so vast that light itself takes more than 22 hours to carry the signal back to us. Their story is one of the great adventures in all of human history, and tonight, you are going to hear every chapter of it from the very beginning, from a young engineer staring at a chart in a California office all the way to the present moment, where two golden machines drift silently through the space between the stars, carrying with them a message from all of us. So before we begin, I want you to take a slow, deep breath in, fill your lungs completely, hold it for just a moment, and let it go slowly. Let your whole body soften as you breathe out. Feel the surface beneath you. Feel your shoulders drop away from your ears. Feel the muscles around your eyes relax. You are safe. You are warm. You have nowhere to be and nothing to do. Let your thoughts slow down like a river reaching a wide, calm lake, and let us begin. Our story starts not with a rocket, and not with a launch pad, and not even with a spacecraft. It starts with a piece of paper and a pencil and a very careful mind. In the late 1960s, a young aerospace engineer named Gary Flandreau was working at NASA's Jet Propulsion Laboratory in Pasadena, California. His task on this particular afternoon was routine. He was calculating the positions of the outer planets, Jupiter, Saturn, Uranus, and Neptune. He was plotting their locations across his charts, tracing their orbital paths the way you might trace the movement of slow clockwork. It was careful, methodical work. Quiet work. The kind of work done in a building full of humming computers, and the smell of coffee, and the soft scratch of pencils on paper. And then Gary Flandreau noticed something that made him stop, something that sent a chill through him, even in the dry, warm air of that California afternoon. In the late 1970s, Jupiter, Saturn, Uranus, and Neptune would all be on the same side of the sun at the same time. They would be arranged in a sweeping arc across the outer solar system, like stepping stones across a very wide river. This alignment was rare, extraordinarily rare. It had not happened in 176 years, and it would not happen again for another 176 years after the 1970s. But the truly extraordinary thing was not simply that the planets would be aligned. The truly extraordinary thing was what that alignment made possible. A spacecraft launched at exactly the right time, on exactly the right trajectory, could fly past all four of these planets, one after another, without needing to carry enough fuel for each leg of the journey separately. Instead, it could use the gravity of each planet to accelerate itself toward the next one, like a stone skipping perfectly across still water. The gravity of Jupiter would fling it toward Saturn. The gravity of Saturn would fling it toward Uranus. The gravity of Uranus would send it on to Neptune. And at the end of that journey, it would be moving fast enough to leave the solar system entirely, to sail out into the space between the stars. Gary Flandreau called this the Grand Tour. And when NASA understood what he had found, they understood that they could not let this window close. The Grand Tour would be possible for only a few years. If they did not launch by the late 1970s, the next opportunity would not come until the middle of the 22nd century. No one in the room would live to see it. So the decision was made. They would build the spacecraft. They would do the work. They would take their chance while the planets were aligned. 2 spacecraft would be built, identical twins, constructed in the same facilities by the same teams. Each one was built around a 10-sided aluminum frame, a structure that was roughly the size and shape of a small car. The total weight of each spacecraft, when fully assembled, was about 722 kilograms. From the body of each spacecraft, a large dish antenna extended outward like the face of a giant sunflower, always turned toward home. This antenna was 3.7 meters across. It was the most important part of either spacecraft, because it was the only way they could speak to Earth, and the only way Earth could speak to them. Scientific instruments were attached carefully around the spacecraft's body. There were cameras designed to take photographs across a range of wavelengths. There were magnetometers to measure the magnetic fields of the planets they would visit. There were plasma detectors to study the streams of charged particles flowing through the solar system. There were instruments to measure radiation and temperature and the charged particles in the environment around them. Each instrument was built to survive not just the initial journey, but potentially decades of operation in the cold and vacuum of space. For power, the spacecraft could not rely on solar panels the way so many satellites do. The sun, at the distances Voyager would travel, would be too faint and too distant to provide enough energy for anything useful. So instead, each spacecraft carried 3 radioisotope thermoelectric generators. These were long cylinders extending on a boom away from the spacecraft's body, containing pellets of plutonium-238. As this material decays naturally, it releases heat. That heat is converted into electricity, slowly, steadily, without any moving parts, without needing sunlight or fuel or any kind of maintenance. These generators would power the spacecraft for decades, slowly losing a small amount of power each year, but remaining functional long past any reasonable expectation. These spacecraft were called Voyager, Voyager 1 and Voyager 2, and before they were launched, before they were sealed and prepared for their journey, someone decided to add one more thing to each of them. Something that was not a scientific instrument, something that was not strictly necessary for the mission, something meant not for the planets ahead, but for the great unknown beyond them, a golden record. But we will come to that in its own time. Voyager 2 launched first. On the morning of August 20th, 1977, it lifted off from Cape Canaveral in Florida on a Titan III Centaur rocket. The sky that morning was clear. The roar of the engines was enormous, felt in the chest of everyone watching, felt in the ground beneath their feet, felt in the air itself. The rocket rose slowly at first, the way heavily loaded things do, and then faster and faster, and the crowd watched it climb until it became a point of light against the blue Florida sky. And then that point of light faded, and the spacecraft was gone. On its way out of the world it had been built in. 16 days later, on September 5th, 1977, Voyager 1 followed. It was launched on a faster and more direct trajectory toward Jupiter. So even though Voyager 2 had launched 16 days earlier, Voyager 1 quickly overtook it in the following months and moved ahead. Voyager 1 would always be the farther of the two. It would always be the one reaching the new distance first. 2 spacecraft now, moving away from Earth at tens of thousands of kilometers per hour, growing smaller with every hour, growing quieter as the signal from their antennas arrived at Earth with less and less strength, and yet always talking, always transmitting, always sending back their steady stream of data, always listening for instructions from home. Your breathing is slowing now. Let it slow a little more. You do not need to think about anything. The spacecraft are moving on their own. The story will keep going. You only need to listen. It took Voyager 1 about 18 months to reach Jupiter. 18 months of sailing through the dark. 18 months of nothing visible ahead except the growing brightness of a planet that was still just a point of light for most of that time. The team back at the Jet Propulsion Laboratory in Pasadena watched the data coming in from the instruments. They checked the trajectory calculations. They made small course corrections when needed, sending commands that took hours to reach the spacecraft and hours more for the confirmation to return. It was slow, patient, careful work. The work of people who understood that extraordinary things take time. When Voyager 1 made its closest approach to Jupiter in March of 1979, the cameras began returning images at a resolution that had never been seen before. Jupiter had always been beautiful from Earth. Through even a small telescope, you could see its cloud bands and its great red spot, and the 4 largest moons as tiny dots of light strung out beside the massive planet. But the Voyager images changed everything that scientists thought they understood about this giant world. The Great Red Spot was revealed in extraordinary detail for the first time. It is a storm, an atmospheric storm so large that 2 complete Earths could fit inside it side by side. It rotates counterclockwise in the southern hemisphere of Jupiter, completing 1 full rotation of the storm about every 6 days. The edges of the storm are sharp and complex, filled with smaller spiral patterns where the edges of the Great Red Spot interact with the surrounding cloud bands. The colors within it range from deep orange-red in the center to pale pinkish white at the outer edges, and the clouds around it are thrown into turbulent waves and knots by its rotation. The Great Red Spot had been observed from Earth since at least the 1600s. For at least 350 years this storm had been raging continuously. Think about that for a moment. 3.5 centuries. Everything that happened on Earth in that time, every empire and revolution and discovery and war. And all that time this storm was simply turning, quietly, endlessly high in the atmosphere of a planet 600 million kilometers away. Jupiter's cloud bands were revealed to be far more complex and turbulent than anyone had imagined. They are not smooth stripes. They are rivers of gas flowing in opposite directions at different latitudes. And where they meet, they create enormous eddies and spirals and rising towers of cloud. Lightning crackles continuously in the depths of Jupiter's atmosphere, bolts of lightning thousands of times more powerful than anything that strikes on Earth. The planet hums with energy that dwarfs anything in our experience. But the greatest surprise of the Jupiter flyby was not Jupiter itself. It was one of its moons. It was Io. Io is the innermost of the 4 large Galilean moons, the 4 moons discovered by Galileo Galilei in 1610 when he turned his small telescope toward Jupiter and watched them move from night to night. Io is roughly the same size as our own moon, but it could not be more different when the Voyager images of Io first came back to Earth. The scientists who received them were expecting to see a heavily cratered world, much like our moon or Mars, a quiet, ancient surface pockmarked by billions of years of asteroid impacts. Instead, they saw something that one scientist immediately compared, in her notes, to a pizza. Io was covered in reds and oranges, and yellows and whites and blacks, the colors of sulfur and silicate rock and flowing lava. And there were no craters, none, because something was constantly erasing them. Io is the most volcanically active world in the entire solar system. When Voyager 1 flew past, 9 active volcanic eruptions were visible simultaneously. 9 plumes of sulfur dioxide gas were rising hundreds of kilometers above the surface and spreading out into enormous umbrella shapes before falling back down again. The surface of Io is constantly being repaved with fresh lava. Old craters are buried under new eruptions before they can build up. The entire surface is being remade continuously, a world that never holds still, a world in a state of perpetual geological upheaval. The reason for all this activity is Jupiter itself. Jupiter's gravity is enormous, and the gravity of the other large moons of Jupiter pulls on Io from different directions as they all orbit. This constant gravitational kneading heats the interior of Io the way squeezing a rubber ball warms it slightly, except in Io's case, the heating is so extreme that the entire interior stays molten. Io is a world powered by gravity, kept alive by the relentless tidal forces of the giant planet it orbits. Voyager 2 followed through the Jupiter system 4 months after Voyager 1. Together, the 2 spacecraft revealed a world and a system of moons that was far more dynamic, far more alive, far more strange than anyone had imagined. They discovered a faint ring system around Jupiter that had not been seen from Earth. They studied the surfaces of Ganymede and Callisto, 2 other large moons. They measured Jupiter's powerful magnetic field, which is so strong that it captures enormous quantities of charged particles and forms a radiation belt so intense it would be lethal to an unprotected human being in a matter of minutes. And then both spacecraft, having completed their work at Jupiter, were flung outward by that massive planet's gravity. Accelerated, sent on their way toward the next destination, Saturn, the most visually beautiful object in the entire solar system. Let your body settle a little more deeply into where you are resting. You are safe and warm. There is nothing you need to do except breathe and listen. The spacecraft are still moving, still sailing, still on their way. Voyager 1 reached Saturn in November of 1980, 3.5 years after its launch from Earth, and what it found there was something that no photograph, no painting, no description had ever truly prepared the scientists for. Because Saturn's rings had been known about since the early 1600s. They had been studied for centuries. They appeared in every astronomy textbook. And yet, when the Voyager cameras began returning detailed images of the rings as the spacecraft approached, the entire science team fell nearly silent. The rings of Saturn stretch outward from the planet's equator to a distance of about 280,000 kilometers from edge to edge. They are made of billions of individual pieces of ice and rock, ranging in size from tiny grains barely larger than dust to pieces as large as a house and some as large as a small mountain. When seen from a distance, the combined effect of all these particles is a smooth, continuous sheet, almost solid-looking. But Voyager revealed that the rings are not smooth and continuous at all. They are made up of thousands upon thousands of individual ringlets, hundreds of thousands of them, each one at a slightly different distance from Saturn, each one moving at a slightly different speed, each one a slightly different shade of cream, or tan, or gold. Some of the rings were braided together in ways that physics struggled to explain. Some had dark gaps where the ice particles had been cleared out by the gravitational influence of Saturn's inner moons. Some had faint, ghostly spoke-like structures radiating outward from Saturn, dark radial features that appeared and disappeared as the rings rotated. These spokes baffled scientists completely. They should not have existed according to any orbital mechanics anyone understood. They are still not fully explained. When Voyager 1 passed through Saturn's shadow and looked back at the rings from the night side, the rings appeared in colors that had never been seen before. Blues and teals and grays and pale golds, lit from behind by the sun's light filtering through different densities of ice. It looked like stained glass held up to a window. It looked like something no human artist could have imagined. The rings of Saturn, seen from up close, at the right angle, in the right light, are among the most beautiful things in the observable universe. Saturn itself, beneath its rings, swirls in soft bands of cream and gold and pale tan. Its atmosphere is similar in structure to Jupiter's, with east-west moving cloud bands, but it looks quieter and softer and calmer in its coloring. But the winds are anything but calm. Near the equator, the winds on Saturn can reach nearly 1,100 kilometers per hour, faster than the speed of sound, continuous, unending, a permanent storm of invisible speed wrapped around a golden world. There was one moon in the Saturn system that the scientists were particularly eager to study: Titan, the largest of Saturn's moons and one of the most remarkable worlds in the solar system. Titan is the only moon anywhere in our solar system with a thick, substantial atmosphere. It is so thick that when Voyager 1's cameras pointed toward Titan, they could not see the surface at all. The entire moon was wrapped in a dense orange haze, a smog made of nitrogen and complex organic molecules, hydrocarbons, the building blocks of chemistry that is related to the chemistry of life. The instruments told scientists that Titan's upper atmosphere contained molecules that are found on Earth only as products of biological processes or as precursors to them. The chemistry was astonishing. It hinted that Titan might be a kind of frozen version of what early Earth looked like before life began here. A place where the same ingredients existed, but in a deep freeze, waiting. What might happen on Titan if it were warmer? Scientists have wondered about this for decades. because of Voyager 1's close approach to Titan. Its trajectory was bent by the moon's gravity in a way that sent it up and out of the plane of the solar system. It could not continue on to Uranus or Neptune. But Voyager 1 had already done something magnificent. It had transformed our understanding of the Saturn system forever. And now it continued outward, up and away from the orbits of all the planets, heading in a direction that would eventually take it completely out of the solar system. Voyager 2 flew through the Saturn system in August of 1981 on a slightly different trajectory, one that preserved its ability to continue to the next planet. Because the Grand Tour was not finished, Uranus was still waiting, and Neptune after that. And Voyager 2 would be the only spacecraft to ever visit either of them. The years between Saturn and Uranus were long and dark. Voyager 2 sailed through billions of kilometers of empty space. The sun, behind it now, grew smaller and dimmer with every passing month. The stars ahead remained unchanged. They were too far away for any amount of speed to make them appear to move. The spacecraft was alone in a way that is difficult to fully comprehend. There are no words in human experience adequate to describe that loneliness, that silence, that distance. But the instruments were still working. The antenna was still pointed at Earth, and the team at the Jet Propulsion Laboratory was still listening, still checking in, still sending commands and receiving the quiet acknowledgement that yes, the spacecraft was still there, still moving, still alive. 4.5 years after leaving Saturn, on January 24th, 1986, Voyager 2 reached Uranus, the 7th planet from the Sun, a world that had been a mystery for as long as telescopes had been able to see it. From Earth, Uranus appeared as a pale blue-green disk with no visible features, no storms, no bands, nothing to see. Scientists expected that up close it might look somewhat like Saturn or Jupiter, perhaps with faint cloud structures. Instead, Voyager 2 found a world of deep, startling strangeness. The first and most remarkable thing was the tilt. Uranus rotates almost completely on its side. Its rotational axis is inclined at 98 degrees relative to the plane of the solar system. If you imagine the other planets as spinning tops standing more or less upright, Uranus is like a top lying flat on its side. It does not spin, it rolls. It tumbles around the sun like a great blue-green ball. The reason for this extraordinary tilt is believed to be a collision. Early in the solar system's history, something very large, perhaps a protoplanet the size of Earth or larger, struck Uranus with enormous force. The impact was so violent that it knocked the entire planet onto its side, and it has remained that way for billions of years. The planet simply never recovered from that ancient blow. It carries the scar of that collision in every rotation it makes. Because of this tilt, the poles of Uranus experience seasons unlike anything else in the solar system. Each pole spends 42 years in continuous daylight and then 42 years in complete darkness as the planet moves through its 84-year orbit around the Sun. The Sun rises at the South Pole and does not set for 4 decades. Then, it rises at the North Pole for the next 4 decades. A rhythm so slow and strange, it is almost impossible to hold in the mind. Voyager 2 discovered 10 previously unknown moons of Uranus during its flyby. It studied the planet's dark, narrow rings, which had been discovered from Earth in 1977 but had never been seen in any detail. It measured the magnetic field of Uranus and found something deeply strange. The magnetic field is not aligned with the rotational axis the way Earth's magnetic field roughly is. Instead, it is tilted by nearly 60 degrees and offset from the planet's center. It is as if someone placed a bar magnet inside Uranus at a strange angle and off to one side. The reason for this unusual magnetic field is still not fully understood. Voyager 2 spent only about 6 hours at its closest approach to Uranus, 6 hours to study a world, and yet in those 6 hours, it gathered more information about Uranus than all of the centuries of observation from Earth combined. Then it aimed its antenna at Earth, reported everything it had found, and continued on its way. Neptune was ahead, the last planet, the farthest one. 3.5 more years of sailing, more darkness, more silence, more patience. And on August 25th, 1989, Voyager 2 made its closest approach to Neptune, the 8th planet, the end of the tour. Neptune was a world of astonishing activity. Scientists had expected it to be quiet, as cold and far from the sun as it was. They were wrong. Neptune was alive with energy in a way that seemed almost impossible at its distance from the sun. The atmosphere was churning. High-altitude clouds of methane ice streaked across the top of the planet like thin white brushstrokes. These clouds were different from the bands below them, moving at different speeds, and they cast visible shadows downward onto the deeper cloud layers. This was the first time shadows of clouds had ever been seen on another planet. It sounds like a small thing. It was not a small thing. It meant the clouds were high enough, and the sun was bright enough, and the atmosphere below them was distinct enough for shadows to form and to be photographed from millions of kilometers away. At Neptune's south pole, a massive dark storm system was visible, an enormous oval of dark cloud rotating in the atmosphere, similar in structure to Jupiter's Great Red Spot, though different in color. The scientists called it the Great Dark Spot. It was roughly the size of the entire Earth. It would disappear a few years later as observed by the Hubble Space Telescope, and then a new one formed elsewhere. Neptune storms come and go, appearing and dissipating over years. Unlike Jupiter's Great Red Spot, which has persisted for centuries, Neptune's great storms are more temporary, though still larger than our entire world. The winds of Neptune are the most powerful in the solar system. They can reach speeds of over 2,100 kilometers per hour. This is faster than the speed of sound on Earth. On a planet that receives 900 times less sunlight than Earth does, on a planet where the average temperature is around minus 214 degrees Celsius, where the sun, seen from Neptune's surface, is just a very bright star, where there is almost no energy arriving from outside, and yet the winds howl. Scientists believe Neptune generates its own internal heat, releasing energy from deep within that drives these extreme atmospheric conditions. But the details remain a mystery. After flying past Neptune, Voyager 2 swung around and aimed for Neptune's largest moon, Triton. And Triton proved to be one of the most strange and beautiful worlds the Voyagers encountered on their entire journey. Triton is large enough that its gravity pulled it into a roughly spherical shape. Its surface is one of the coldest places in the solar system, with temperatures around minus 235 degrees Celsius, almost as cold as it is possible for a world to be while still being a world. At these temperatures, nitrogen, which is a gas at room temperature on Earth, exists as frost on the ground. The surface of Triton is covered in pale pinkish-white nitrogen frost. It is a frozen, still, silent world at the very edge of the solar system's warmth. And yet Triton is active. As Voyager 2 flew past, the cameras captured something that no one had expected to see. Geysers, active geysers of nitrogen gas, erupting from beneath the surface of this frozen moon. Dark plumes of gas and dust shooting several kilometers straight up into the thin atmosphere, then being caught by the gentle winds and swept sideways, creating long, dark streaks across the pale frost of the surface. A world that seemed by all rights to be completely frozen solid and completely dead, erupting, quietly but continuously, sending dark columns of gas up into the dark sky above it. The reason for Triton's internal activity is believed to be related to the way sunlight, even as faint and distant as it is at Neptune, heats the surface nitrogen slightly during the long polar day. This can create pockets of warming gas beneath the surface that eventually build up enough pressure to erupt. A world powered by the faintest possible warmth from a star that is barely brighter than the other stars in its sky. There is one more remarkable thing about Triton. It orbits Neptune backwards. Every other major moon in the solar system orbits its planet in the same direction as that planet rotates. This is because moons generally form from the same disk of material that the planet itself formed from, and so they naturally end up orbiting in the same direction. But Triton orbits Neptune in the opposite direction. This retrograde orbit is unmistakable evidence that Triton was not born alongside Neptune. It was captured. Long ago, Triton was something else entirely, perhaps a dwarf planet wandering in the outer solar system, perhaps a Kuiper belt object like Pluto drifting free on its own path around the sun, until it came close enough to Neptune that the giant planet's gravity reached out and pulled it in, captured it, made it a moon, and Triton has been orbiting Neptune ever since, slowly being drawn in by tidal forces on a path that will eventually, in hundreds of millions of years, bring it close enough to Neptune that it will be torn apart by gravity and form a ring system around the planet. With Neptune and Triton behind it, Voyager 2's planetary mission was complete. The grand tour that Gary Flandreau had envisioned in that California office in the 1960s was finished. 4 planets, dozens of moons, rings and storms and volcanoes and geysers and frozen oceans and ancient mysteries, all of it seen for the first time, in detail, by 2 small machines built by human hands. And now both spacecraft turned their antennas home, reported everything they had found, and kept going. Outward, always outward, into the growing dark. Your breathing is very slow now. Let it slow just a little more. Feel the weight of your body, warm and comfortable. The spacecraft are still moving. They do not need you to guide them. They know where they are going. You only need to rest. On February 14th, 1990, Voyager 1 was about 6 billion kilometers from Earth. It had traveled beyond the orbit of Neptune. It was on its way out of the solar system entirely. And on that day, at the request of the astronomer Carl Sagan, NASA sent a command to the spacecraft. A simple command: turn around, look back. Voyager 1 rotated its camera platform, and over the course of several hours, it took a series of photographs. It photographed the solar system it had traveled through. It photographed the sun, now just a bright star in the distance. And in one of those photographs, in a beam of scattered sunlight, barely visible, smaller than a single pixel, there was a tiny point of pale blue light. Earth. This photograph became known as the pale blue dot. Carl Sagan wrote about what it means. He wrote these words: "Look again at that dot. That is here. That is home. That is us. On it, everyone you love, everyone you know, everyone you ever heard of, every human being who ever was, lived out their lives. The aggregate of our joy and suffering, thousands of confident religions, ideologies, and economic doctrines, every hunter and forager, every hero and coward, every creator and destroyer of civilization, every king and peasant, every young couple in love, every mother and father, hopeful child, inventor and explorer, every teacher of morals, every corrupt politician, every superstar, every supreme leader, every saint and sinner in the history of our species lived there. On a mote of dust suspended in a sunbeam, let those words rest with you for a moment. A mote of dust suspended in a sunbeam. That is what this planet is, seen from the edge of the solar system. That is what everything is, from far enough away. And yet it contains everything, every story ever told, every kindness ever given, every meal shared between people who love each other, every song ever sung, every child ever born, all of it on that tiny pale blue dot. Now let us talk about the golden record, because both Voyagers carry with them something extraordinary, something that was placed on each spacecraft, not for the planets they were visiting, but for the unimaginable future, for whatever might, in some distant age, find a small machine drifting silently through the space between the stars. The golden record is a 12-inch gold-plated copper disc, similar in shape to a vinyl record. It is enclosed in an aluminum jacket. On the outside of this jacket, information is engraved in a language of mathematics and diagrams that scientists believed any sufficiently advanced intelligence might be able to decode. Instructions for how to build a device that could play the record. Instructions for how to interpret what would be heard and seen. A message in the universal language of physics. The content of the record was assembled under the direction of Carl Sagan and a committee of scientists, artists, musicians, and thinkers. They had one question to answer. If you could send one message to the universe, what would you say? They chose to say everything they could fit. First, they included sounds, the sounds of Earth, the sound of thunder rolling across a wide-open sky, the sound of rain falling on leaves in a forest, the sound of wind moving through tall grass, the sound of ocean waves arriving on a beach and pulling back and arriving again, the sound of crickets on a warm night, the sound of frogs calling to each other across still water, the sound of birds in the morning, the sound of a human heartbeat, steady and soft, the sound of footsteps on a path, the sound of a fire crackling, the sound of laughter, the sound of a mother speaking her first words to her newborn child. All of these sounds were chosen because they speak without needing language. They speak in the language of experience. Anyone who has ever heard rain or heard the ocean, or heard someone laughing, knows immediately what those sounds mean. They are the sounds of a living world, a warm world, a world where things grow and move and breathe. Then there are greetings. In 55 different human languages, a sentence or a phrase, each one saying in its own way, "Hello, we are here, we hope to meet you." The oldest languages recorded include Akkadian, a language spoken in ancient Mesopotamia more than 4,000 years ago, and Sumerian, one of the oldest written languages in human history. These are languages that no living person speaks as a native tongue, languages preserved only in clay tablets and academic study, and yet their words are now traveling between the stars. Carried on a golden record past the boundary of the solar system, the voices of civilizations long gone, reaching further into the future than any of them could have imagined. Then there is music. 90 minutes of music, chosen to represent the full breadth of human musical expression across cultures and across history. There is Johann Sebastian Bach, the Brandenburg Concerto No. 2, played with mathematical precision and luminous beauty. There is Louis Armstrong playing and singing melancholy blues, his trumpet and his voice together telling something true about what it means to feel. There is a Javanese gamelan orchestra, a cascading interlocking music of bronze and wood that sounds like rain falling on metal in a beautiful rhythm. There is a Peruvian wedding song, a Bulgarian folk song, a Navajo night chant sung in a desert under stars. There is a Senegalese percussion performance. There is a Pygmy Girl's initiation song. There is an Azerbaijani bagpipe piece. There are panpipes from the Solomon Islands. There is a Georgian choir. There is Beethoven's Fifth Symphony, one of the most recognized pieces of music in human civilization. And there's Chuck Berry's Johnny B. Good, a song of pure, joyful electric energy that seems to say better than almost anything else that human beings find pleasure in sound and rhythm and the expression of feeling through music. These musical choices were made to show the full range of what music means to humanity, that it is not one thing, that it is not one culture's invention, that every human civilization that has ever existed has made music in every corner of the earth, in every climate, in every language, in every century. Music is what human beings do. It is one of the most fundamental expressions of being human that exists. And then there are 116 photographs encoded as audio signals on the record. Images of Earth from space. Images of the continents and the oceans and the clouds. Images of a man and a woman, their silhouettes shown to convey human scale and shape. Images of people eating around a table together, children playing in a yard, a family, a sunset, a library full of books, a supermarket, a highway, an airport, an ocean liner, a train, people skiing down a snowy mountain, people fishing from a boat, athletes running, a school classroom full of children looking at a teacher, people at work, people resting, a house being built, the Great Wall of China winding across its mountains, a diagram of the human ear, a diagram of the structure of DNA, a mathematical sequence demonstrating that the makers of this record understood the language of numbers. These images were chosen to show what Earth is, what its people look like, what they do, how they live. They were chosen to be honest and representative, to show both the ordinary and the remarkable, to say here is a species, here is what they have made, here is how they spend their days. There is also a spoken message from the Secretary General of the United Nations at the time, Kurt Waldheim, and a message from the President of the United States, Jimmy Carter, which reads in part, "This is a present from a small, distant world, a token of our sounds, our science, our images, our music, our thoughts, and our feelings. We are attempting to survive our time so we may live into yours. We are attempting to survive our time so we may live into yours." Read those words slowly. Let them settle. That is what the golden record is. It is an act of hope, an act of reaching out into an unknown future with open hands and saying, "We were here. We existed. We made things of beauty and complexity. We felt things. We thought about the universe and wondered what was out there. And if you find this, and if you understand it, please know that we tried to survive our time. We tried to be worthy of the universe we found ourselves in. These two golden records are right now the most distant human objects in existence, moving through the space between the stars. They will outlast every building humanity has ever built, every city, every civilization, long after the sun has grown old and changed, and this earth has become unrecognizable. The golden records will still be traveling, still carrying the sound of rain and the sound of thunder and the sound of a mother's voice and the music of Bach and the laughter of a human being who felt something joyful in a moment that is long past. If no one ever finds them, they are still one of the most beautiful things humanity has ever made. A gesture of hope cast into the infinite, a message in a bottle thrown into an ocean with no shores. And now, in the final part of our journey tonight, we follow the spacecraft to where they are right now, to the place no human object had ever reached before they got there. For decades after their planetary flybus, the Voyagers sailed outward through the heliosphere. This is the region of space dominated by our sun's influence. The sun continuously exhales, sending a stream of charged particles flowing outward in all directions at high speed. This is called the solar wind. It fills the heliosphere the way air fills a balloon, creating an enormous bubble of solar influence that extends far beyond the orbit of even the most distant planets. The Voyagers were inside this bubble for decades. Still, in some sense, inside our solar system, but gradually, as the spacecraft moved further and further from the sun, the solar wind weakened. It slowed, like a very long breath finally running out, and at the point where the solar wind finally stops, where it runs out of energy and merges with the material between the stars, there is a boundary. Scientists call it the heliopause. Beyond it is interstellar space, the space between solar systems. The true void. Voyager 1 crossed the heliopause on August 25th, 2012, 35 years after it was launched. It was the first human-made object to enter interstellar space, the first thing ever built by human hands to leave our solar system. When scientists confirmed the crossing, after months of analyzing the data to be sure, the emotions in the room at the Jet Propulsion Laboratory were difficult to describe. Some people cried. Some stood in silence. Some shook hands quietly. A machine they had launched 35 years earlier that had traveled farther than any object in human history had crossed the final boundary. It was in the space between the stars. Voyager 2 crossed the heliopause on November 5, 2018, 41 years after its launch. It followed its twin into interstellar space, becoming the second human-made object to leave the solar system. Both spacecraft still operate today. Both still communicate with Earth. The team at the Jet Propulsion Laboratory still listens to them, still sends commands, still receives data. The signals they send are almost unimaginably faint by the time they arrive at Earth. The power of the radio signal from Voyager 1, when it arrives at our receiving antennas, is less than 100 billion billionths of a watt. A signal that vanishingly small requires some of the largest radio antennas ever built to detect. And yet we detect it. We listen for it every day. Scientists and engineers whose parents were not yet born when Voyager 1 launched now work to keep it alive, to keep its antenna pointed at Earth, to squeeze every last piece of scientific data from its aging instruments. The power generators lose a small amount of power each year. Instruments have been switched off one by one to conserve energy, but both spacecraft are still transmitting, still measuring the environment of interstellar space around them, still sending home what they find in that dark and distant place where no instrument has ever gone before. Voyager 1 is currently moving at about 61,000 kilometers per hour. It will not come close to any other star for about 40,000 years. And roughly 296 years, it will begin to pass through the Oort cloud, the vast distant shell of icy objects that surrounds our solar system at enormous distance. It will take approximately 30,000 years to pass completely through it, and on the far side, it will be in the true space between solar systems. Moving through a darkness that stretches for light years in every direction, with nothing ahead of it for an incomprehensible time, and it will carry the golden record. The sound of thunder, the sound of rain, the sound of laughter, the music of Bach and Louis Armstrong, and a pygmy girl's song and a Navajo night chant, the sound of a human heartbeat, all of it drifting through the dark, patient as starlight, patient as deep, bottomless sleep. It is time to come home now. You have traveled very far tonight. You have seen volcanoes erupting on a moon of Jupiter. You have drifted through the rings of Saturn, lit from behind in blue and gold. You have stood over the south pole of Triton and watched dark geysers rise into a frozen sky. You have seen the tiny pale blue dot that is everything, and you have followed two golden machines to the edge of everything we have ever known, and a little beyond. Now let the universe carry on without you watching. It will keep going. Jupiter's storm will keep turning. Saturn's rings will keep glittering. Voyager 1 will keep moving. It does not need you to watch. It has been moving for nearly 50 years, and it will keep moving long after every person alive today is gone. Some things in the universe are very patient. Some things simply continue. You feel your breathing settling into a slow, comfortable rhythm. You feel the warmth of where you are lying. You feel the quiet around you. This is your world, this small warm room and this small warm life on the most beautiful pale blue dot in the known universe. And somewhere above you, 400 kilometers above you in fact, the International Space Station is moving through the sky right now, carrying human beings who are looking down at Earth and feeling exactly what you might imagine they feel. That overwhelming sense of love for this planet, this one fragile living world, and somewhere beyond them, far beyond them, Two small golden machines are moving through the dark between the stars, carrying our voices, carrying our music, carrying the sound of rain on Earth, moving forward without stopping, without slowing, without ever looking back. Let your thoughts grow softer now. Let the last images of the journey fade into the comfortable darkness behind your eyes. The rings of Saturn, the gazers of Triton, the pale blue dot, the golden record, all of it settling down into the quiet place where sleeping things rest. You are made of atoms that were forged in stars that lived and died billions of years before this Earth existed. You are not separate from the universe. You are part of it, a piece of it, resting here, warm and breathing, in the dark. The same dark that the Voyager sailed through, the same universe that holds Jupiter's storm and Saturn's rings and Neptune's impossible winds. You are inside all of it, and it is inside you. Sleep now. Let everything else wait. The universe is patient. It has been here for 13.8 billion years. It will be here tomorrow, and the day after, and long, long after that. The Voyagers are still moving, still talking, still carrying our voices into the dark. And you are here. Safe, warm home, sleep well. Good night.